There are two types of VNAV descents, path and speed. Each descent is flown differently, but the FMC uses the same descent profile with a speed or path descent. In a path descent, the FMC controls pitch to stay on the descent profile. You must monitor and adjust the speed. In a speed descent, the FMC controls pitch to stay at a target airspeed. You must monitor and adjust the descent to stay on the desired descent profile. Let's see how the descent profile is calculated. The FMC starts with the end of descent point. The FMC then calculates a path for approach speed reductions and flap extensions. Before the approach, the FMC assumes descent with idle thrust, flaps, and gear up, and speed breakdown. The FMC makes a top of descent point where the descent profile and cruise altitude come together. The FMC adjusts the descent profile for speed reduction at the airport speed restriction altitude. This moves the top of descent back and shortens the cruise phase. The FMC adjusts the descent profile for waypoint speed or altitude constraints. This moves the top of descent back and shortens the cruise phase again. Winds and temperatures also change the descent profile. When you put in forecast winds, the FMC adjusts the top of descent. The FMC uses all of these to calculate the top of descent point. The result is the most economical descent for the route and weather. The end of descent is near the destination airport or near the destination runway. If you do not put in an approach, the FMC assumes a straight line between the last waypoint on the flight plan and reference airport or runway. If you select an arrival or approach, the end of descent point is the last waypoint in the descent with an altitude constraint. You are 50 miles from top of descent. Show the descent page. Show the descent forecast page. You put in forecast ISA deviation, QNH, and winds for up to 3 altitudes on this page. Put in the ISA deviation and QNH. You can put in up to 3 winds in any sequence. Put in the wind for flight level 210. For this example, put the wind on the first wind line. Put in the wind for 15,000 feet. For this example, put the wind on the second wind line. Execute the modification. Show the cruise page. The distance to the top of descent changes. A path descent is the most economical descent. During a path descent, the FMC controls pitch to stay on the path. You possibly have to use thrust or the speed brake to keep the airspeed you want. Usually, to make a path descent, you should also engage LNAV. If you do not engage LNAV, you must be near the LNAV path. "5 miles from top of descent, the FMC scratchpad message Reset MCP Altitude shows. Reset the MCP altitude. The FMC automatically commands a descent when you pass the top of descent point. The descent page shows automatically. The FMC commands idle thrust. The pitch mode stays VNAV path, and the FMC controls pitch to stay on the path. The speed restriction line shows the airport speed restriction for your destination. You can put in a different speed and altitude restriction. Green circles on the navigation display map mode show where the deceleration segment starts and stops. When you are near the airport speed restriction altitude, the descent path angle decreases. The FMC commands higher pitch and the airplane slows. As speed decreases below the speed restriction, the FMC commands lower pitch to descend below the airport speed restriction altitude. The FMC commands a speed 10 knots lower than the airport speed restriction. In this example, the airport speed restriction is 250 knots below 10,000 feet. The FMC commands 240 knots. This gives a buffer for small airspeed changes. Information about the next waypoint with an altitude constraint shows here. If there is a waypoint with an altitude constraint, the path will come to the altitude at the waypoint. After the waypoint, the path is level. When the airplane comes to the next idle thrust path, the FMC commands idle thrust and lower pitch to follow the path. When you are close to the destination airport, the FMC commands flaps up maneuvering speed. Set flaps 1. When you extend flaps, the FMC commands speeds for the flap positions and your weight. If you do an ILS approach, VNAV disconnects at glide slope capture and the MCP speed display opens. Next, we will do the same descent using speed descent mode. You are level at cruise, near top of descent. Show the descent page. The FMC defaults to a path descent. If a speed descent is necessary, you usually have to select it. But if there is no altitude constraint at a waypoint in the descent, a path descent is not available. In this example, a path descent is available. Push the line select key adjacent to speed. Execute the modification. The speed descent page shows. Although the speed and path descent pages look mostly the same, the descents are very different. Recall that a path descent is the most economical descent. A speed descent is more flexible than a path descent. During a speed descent, the FMC controls pitch to stay at a target airspeed. The FMC does not try to stay on the path. Thus, a speed descent is less economical. You will possibly have to use the speed brake or thrust to stay on the path you want. You can stay on the VNAV path or a different path. You can engage other roll modes during a speed descent. You do not need to be near the LNAV path. Reset the MCP altitude for descent. In this example, with no altitude constraints, the FMC automatically commands a speed descent when you pass the top of descent. The FMC commands idle thrust. The pitch mode changes to VNAV speed. And the FMC controls pitch to stay at the target airspeed. Remember, you are responsible to stay on the path. When you are near the airport speed restriction altitude, the FMC commands higher pitch and the airplane slows. The pitch mode temporarily changes to VNAV path as the FMC controls pitch to stay on a path above the airport speed restriction altitude. In this example, the airplane is below the VNAV path. The FMC does not try to go back to the path. As speed decreases below the speed restriction, the FMC commands lower pitch to descend below the airport speed restriction altitude. There is a waypoint with an altitude constraint. Recall that in a path descent, the FMC commands level flight after reaching the waypoint. During a speed descent, the FMC will make sure you make the altitude constraint. Then the airplane will continue to descend to the next altitude constraint. At the altitude constraint, the FMC commands level flight until you pass the waypoint. The FMC temporarily increases thrust to keep the target speed. The pitch mode temporarily changes to VNAV path. The FMC commands slower speeds for the approach and flap extensions, the same as a path descent. If you do an ILS approach, VNAV disconnects at glide slope capture and the MCP speed display opens.